Good day everyone, my name is Ibrahim Olagoke. Welcome to another chemistry class. Today we'll be taking chemical reactions, and the outline for our study for today goes thus: the rate of chemical reaction, which is kinetics, and it deals with the rate of the reaction, that's how quickly products are formed or reactants are converted. Thermodynamics, which involves the change in energy that occurs in a chemical reaction. Now, this rate, that's kinetics, is concerned with the moles of reactants converted per unit time, or the moles of product formed per unit time. Now, this depends on the frequency of collision of the molecules. The faster the collision, the faster the rate. And this, to have effective collision, you need to have a proper orientation and enough energy to move the reactants to form products. Now, basically, in thermodynamics, we're talking about the heat content here, which is the enthalpy, the amount of heat absorbed or released in a chemical reaction. This is denoted by delta H, enthalpy, and it is the difference between the heat of product and the heat of reactant. Heat of the reaction, delta H, can be positive when heat is absorbed from the surrounding, and it's called an endothermic reaction. Here, the heat of the product are greater than the heat of the reactant, while it could be negative when heat is given out to the surrounding, and this is called an exothermic reaction. This is where the heat of reactants will be greater than the heat of the product. Looking at the diagram, for the exothermic reaction, heat is released to the surrounding and it makes the surrounding warmer. Here we'll have the reactants to give the product an energy, while for endothermic, heat is absorbed, making the environment cooler, and the reactant plus energy gives off the product. Now, the minimum energy required to move the reactant to give the product is called the activation energy. Talking about the factors affecting the rate of chemical reaction, we have basically four factors. One, temperature. With an increase in temperature, there is an increase in collision, and this increases the rate of the chemical reaction. Now, the second one is surface area. When you have a large surface area, this also enhances how reactants collide, and this increases the rate of chemical reaction too. Then we have concentration. When concentration is increased, the rate of reaction also increased. And lastly, we have the surface, the catalyst. Now, the catalyst is a substance that enhances the rate of chemical reaction. We'll have the positive and negative to catalyst. The positive increases while the negative decreases the rate. Now, the homogeneous catalyst is present in the same phase as the reacting molecules, while the heterogeneous is present in a different phase than the reacting molecule. The basic function here is the catalyst reduces the activation energy. Like you can see in the diagrams, there's a dotted line on the energy diagram. That dotted line is the decrease in the activation energy, hence reduce the time for the reaction to proceed. So basically, catalyst reduces the time, reduces the rate of the chemical reaction. Now, the energy is the capacity to do work, and it could be in potential energy, kinetic energy, or thermal energy. Now, that's what we're concerned with here. That's delta H, the heat energy released or absorbed during the process. The unit here is joules, and it concerns the bond breaking and bond making. The instrument used in measuring this heat is called the calorimeter, and a typical example is when you are reacting two molecules of hydrogen and a molecule of oxygen to form water. There is a bond breaking in hydrogen and oxygen, while a new bond is formed in water. Now, when you take the difference between these two heats, you have the heat of reaction. And in this case, it's endothermic since we have minus 506 kilojoules. Now, let's look at a last concept here, which is entropy delta S. This is the degree of disorderliness of a system, or the randomness of a sample. And basically, this is found in gases, highest in gases. Gases have higher entropy, while solid have a low entropy because of the randomness. Now, phase change from solid, liquid, and gas determines the increase in the entropy. Now, in mixing gases also, there's also an increase in entropy since there's more collision because of the agitation. When you're dissolving a substance also, it causes an increase in entropy. Now, our assignment for today is you have to explain the following terms: kinetics, thermodynamics, and two, you have to state the factors affecting the rate of a chemical reaction. Thanks for listening.